The third of three fossil fuels that we're going to talk about is natural gas. Now, it's the one that you probably know the least about, yet it's the one that's having the largest impact today. Why is it the one that's having the largest impact today? Well, we know what coal does and we know what oil does, but for a long time, natural gas wasn't really easy to attain, or we weren't really sure what to do with it. But we do know what it is, and we know it's about 50 to 90% methane. Methane is CH4. You might want to remember that. It has some smaller amounts of other stuff, but it's mostly methane, and methane is going to be a key player in greenhouse gases. Now, we all know about carbon dioxide and CO2, and everyone talks about how bad CO2 is, but actually methane's pretty bad and actually kind of worse, and we're going to talk about why that is. As a gas, we went from solid to liquid to gas. As a gas, it's the most difficult to transport. You have to do a bunch of stuff to it or shrink it down, or it takes a lot of energy to kind of do that. And it often exists near where oil is, but for a long time, and even still, if we don't have a way to transport the gas, then it doesn't really do much good for us. Why is it making such a resurgence, or I guess a introduction to the market in the last, 10 years or so? Well, one of the big things is that while the other ones are really bad at polluting stuff, the only thing that natural gas is going to emit, or the only kind of byproduct from it, is going to be carbon dioxide and water. Now, yes, carbon dioxide is still there, and yes, carbon dioxide is still bad, but remember when we talked about, sulfuric acid and sulfur dioxide and nitrous oxide and all those things? Well, this has carbon dioxide and water, and that's a lot more manageable than what the other ones were. So why the last 10 years or so? Well, something you've probably heard about. The actual name of it is called hydraulic fracturing. You probably know it as fracking. What is fracking? Controversial for one, but two, it's the most recent way that we've found to get natural gas out of the ground. And as we are able to put more money into these fracking things, we're able to get more natural gas, and we've actually transitioned from some coal power plants over to natural gas plants. And again, pros and cons to everything. And I'm not here to be the arbiter of what energy source that we should be using, but just know that that's one thing that we've been doing, is moving to a little bit cleaner natural gas. Now, if someone tells you it's clean, they're lying, but if they say it's cleaner, that's definitely true. What do you have to do to frack? What do you have to do to have this hydraulic fracturing process? Well, you basically take a bunch of water and a bunch of chemicals and you pump it into the ground, and you literally put so much into the ground that the rocks fracture. That's why it's called hydraulic fracturing. You put so much hydraulic fluid and hydraulic pressure into these rock formations that they literally fracture and they break. And then you put a bunch of sand down there, and after all this stuff happens, after the chemicals do their thing, then you're able to get the gas out of the pocket that geologists like myself have gone and found, and the companies have gone through and done the fracking process too. Now, not only is it kind of controversial because it's using a fossil fuel, that's one thing, but there's two other main issues that you need to know about with fracking. The first one is that it takes a lot of water. I'm talking millions of gallons per fracking site, per fracking well, to get this process rolling. Millions with an M gallons of water. The other thing is what happens to that water when it comes back to the surface. That's called flowback. And there's a bunch of chemicals in this water. And do not let anyone tell you, oh, it's made of chemicals, it's bad. Everything is a chemical. Everything is a chemical. Because it's a chemical doesn't mean it's bad. What's bad is that there's a bunch of stuff in it that these companies don't have to disclose. And you can argue for or against that, whatever, if you want to get into that side of it. But I'm not here to discuss that. What I am here to discuss is the fact that because they don't have to do that, we do know that there's carcinogens and endocrine disruptors in them, and that people can get sick. And while there's been no known underground, accidents or processes that have caused leaking into the groundwater, there have been surface problems and getting into surface water. And when, residents nearby have their surface water, their drinking supply, contaminated with these unknown chemicals, it can definitely cause a problem, and it's something that we should be wary of. Now, again, I'm not here to say which way you should be using, and if it's a pro or if it's a con. I'm here to just tell you the scientific pros and cons to each one. Why then go through all this if it just sounds like I'm telling you nothing and not taking a side and I'm just meh, 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 meh? Well, because you need to understand this moving forward because it's going to be part of your future. Yes, mine too, and I'm not that much older than you, but I'm still older than you. And my future and your future kind of depends on what energy choices we make. Right now, fossil fuels still make up about 80% of the entirety of United States energy production. And while that number has fallen, even since I've been teaching, which hasn't been that long, it's still a huge majority of our energy. And while renewables have gone from 9 up to 11 up to, I've even seen 13 in my recent research, that's still a small fraction of energy made by renewables in the United States. What's left? Nuclear power, which is what we're going to get into next. However, why care about this? Well, one, we live here. Two, we are one of the largest emitters of fossil fuel pollution and products and byproducts in the world. Guess who's number one? I'll give you two guesses and one doesn't count. Not only is it per capita, but it's also just a gross total of who is emitting the most. We're in the top two and doesn't look like that's going to change anytime soon. And as we get into climate, we're going to talk about the agreements that we have and haven't made in places like Kyoto and Paris, and what we've done and not done and decided we don't want to do anymore, and what that means moving forward and why that links up to this unit so well. However, us, you, me, people that live in the US for the most part, people that live in the Western world, or in Western Europe especially, while we're only about 20%, 30% of the population, we do take up a huge majority of who is using this energy. So even though it's not that much population-wise, we use a lot of it per capita. So even, you and I and your friends and your mom and your dad, your uncle, your aunt, and whatever, might not use that much by yourself. There's 330 million of us just in this country alone. There's over 1 billion in India and China. We're going to talk about what that means, and maybe you can't make a huge difference yourself, but I bet if you made a little difference and they made a little difference and he and she and they made a little bit of a difference, maybe? I don't know. What are we going to do after this, though? We've gone through all the fossil fuels and we've talked about some pros and cons, and we've gone through it in more detail in class. So if we can't use or we shouldn't use or we should move away from those, what do we change to? I don't know. Nuclear energy?